All right, hi everyone. Hi everyone. My name is Jose with Lowell Observatory. I'm one of the senior public program educators, and welcome to our interactive stargazing live stream. So if you are joining us for the first time tonight, then I'll have you know this is where we all it's like a little virtual star party where we over here at Lowell Observatory will feature some various objects that are up in the sky at the time. We have a camera, we have our Malin camera attached to our 14-inch planewave CDK telescope over at our Geo Valley Open Deck Observatory. And we'll take images with that camera and then feed them live to you guys, so you guys can see some really cool stuff. And we have it open for any requests that you want to see. You can go ahead and leave some of those requests in the chat and we'll get to them. And we'll probably be doing this for about 30 minutes to 45 minutes or so. And so what we're looking at here on the screen, you can see a galaxy. And this galaxy is actually edge on, so you don't get to see the unique spiral structure that it may or may not have. We're looking at it from a different angle. You can imagine galaxies oftentimes are going to be like dinner plates. They're going to be flat disks, and we're looking at this dinner plate edge on. And if we were to look at it face down, we might see some spiral arms. This type of galaxy right here, this is called a lenticular galaxy. It's got this unique little dust lane just going, this little black stripe going right across the central bulge of the galaxy. And at the very center, that's where the majority of the stars in the galaxy are located. So probably about, I'm gonna probably say maybe about a third of the stars of the whole galaxy are all located at the very center there. And this particular galaxy, this is Messier 102 or 102. So Charles Messier, he's pretty famous in the astronomy world. He created one of the very first astronomical catalogs, and he has 110 objects on his list. And so this is 102 on the list. And him and several of his colleagues discovered many of these Messier objects, and this is one of them. There's been some hot debate actually among astronomers as to whether or not on the original catalog, whether they were referring to this particular galaxy as Messier 102, or if it was another galaxy. Turns out that Messier's colleague Pierre Messier, who discovered this one, thought that it might have been a duplicate observation of Messier 101. But we're looking at NGC 5866, which is what most people tend to agree is actually M102 right there. This one can be found over in the northern sky in the constellation Draco. And I love these lenticular galaxies. I think this one's a little bit of an underdog because there's quite a few that are out tonight. And I don't think this one gets as much love as some of the other ones, like the Sombrero Galaxy. So I thought I'd shower this one with a little bit of extra attention. Now, this one's about 50 million light years away. And it's also about just a little bit more than half the size of our galaxy, at about 60,000 light years across. So this one's a little bit smaller for a galaxy, spiral galaxy anyway. Now we are going to see over some time for the course of tonight, we're going to have a little bit of quality change in the pictures from frame to frame, because we do have a few clouds that are still lingering in the air. Most of today has been pretty cloudy here in Flagstaff. And so we might see the quality of picture change, and that's just because of our atmospheric conditions that we have. Although it is still clear enough that we should be able to get most of the things that are up tonight. Now I'm going to go ahead. I'm going to see if we have any requests. I haven't seen any requests in yet, so I think that since we were just talking about this one being confused with Messier 101, why don't we have our telescope operator point that over to M101 now, which is the Pinwheel Galaxy. And this is a pretty good, this is another galaxy. And so we just looked at one that was edge on, right? It's the side of the dinner plate. And now we're going to be looking at one that's actually face on. And we're going to be looking straight down at our dinner. We're going to see the spiral arms on this one. So again, you can put in any requests that you want. There's all sorts of cool things out in the sky. We got some cool binary stars, galaxies, globular clusters. Most of Leo and Virgo, Ursa Major, and Draco. So those ones are all up tonight, as well as some others that I forgot what they're called right now because I'm thinking about this galaxy. You can sort of see it starting to pop out there. So once we get that exposure turned up a little bit more, it should be able to pop up pretty easily. And we can actually tell we can see the spiral arms pretty clearly already. So once they get that their situation all set up over there at the camera, you can see that we're taking 24-second exposure pictures. And there's a little progress bar down at the bottom that you can watch, right? And you can see there is a little bit of a spiral structure, these little bright splotchy areas kind of throughout the whole picture. And at the very center, there's that bright area. That's, again, the central bulge, a little bit overexposed. We'll try that again. There might be a cloud passing in front of it. Sometimes this happens. And this one, and Messier 101, this one is considered a grand design spiral galaxy. That's the official name for these galaxies that are kind of perfect in structure. And it looks like what you would think a typical galaxy would look like if you just sat there and you thought, oh, what's a galaxy look like? This one might come up. Yeah, it was definitely a cloud for sure. Right. So we'll give this a couple more tries to see if we can get some good pictures of it before we move on. Just so you guys can see a really nice galaxy at the very center. This one, actually, you'll see if we get it good, we'll actually see one of those spiral arms has kind of been straightened out a little. It's not perfectly grand design. And it turns out this has undergone some gravitational interactions with another galaxy. It seems like that cloud doesn't really want to move around. So let's go ahead and point the telescope to, we have a couple requests in now. So we have John Scarangello has requested Messier 105. So that's an elliptical galaxy near Leo, about 36 million light years away. So we're going to go ahead and, I haven't actually seen this one through the Melon cam at all, so I'm pretty excited to see how it's going to be. I like elliptical galaxies. Again, they are I would like to consider them as like underdogs because people really like those spiral galaxies, and like these lenticular galaxies always look pretty nice. And elliptical galaxies tend to look like little clouds, and they don't get as much love. But these ones, once we see the picture there, yeah, these ones, they kind of, there's actually two. If we can zoom out a little bit, there are two elliptical galaxies and a spiral galaxy in this picture. Messier 105, I believe, is the one on the far left there, just because I have a pretty good idea of where the object in question is supposed to be centered when the telescope first moves to it. But yeah, we actually have a couple galaxies. And that's because this one, being located in the constellation Leo, lies very near our Virgo supercluster, which is a large cluster of galaxies located in that part of the sky. And there's hundreds of galaxies out in that direction. So the springtime, when Leo and Virgo are up high, is the best time to catch galaxies, because you can pretty much point a telescope anywhere and you'll see one. Now, these galaxies here, or sorry, that little galaxy I said was a spiral looks more like a regular galaxy upon further inspection. Sorry to misinform you all. But these little elliptical galaxies here, they're probably not little, actually. They're probably very large. In fact, they're much larger than our own Milky Way galaxy because they're the result of the collisions of multiple galaxies over lots of time. As it turns out, galaxies are, in fact, cannibals. We call it galactic cannibalism when a big galaxy absorbs another galaxy. And when they undergo interactions like this, they tend to lose their spiral structure. They're no longer as orderly as they might be, because stars are starting to come from all different directions. And they don't have as much angular momentum as a spiral galaxy would. So yeah, Messier 105 is the one over there, right on the left-hand side. Although I'm not too sure what those other two are. All right. We have another request. Jasmine, hi Jasmine, has requested Lunar X, and that's on the moon. So let's go ahead and see if we can get that. Now we have Lunar X and Y, and I can have the operator correct me if I'm wrong, but there are these features that if the shadows are just right, on the moon, they look like an X and a Y. So let's see if we can find it, and if the operator can help me out here as well, because I'm not too sure where I'm supposed to be looking. Oh, the moon's gone. So what our operator is doing, Nina, is adjusting the exposure time. We actually put this camera into video mode because it will do shorter exposures, and it allows us to, we can change the quality of the image. And yeah, actually right up towards the top, right underneath some of those big craters, you can see right on the shadow there. I think that's what I'm looking at anyway. I might be really wrong. But yeah, the little hand, the little mouse there, they're hovering over where it's supposed to be. Yeah. So that is so we have a picture of the moon, and then of course we have our request here, the Lunar X, and I couldn't tell you where Y is. They know. But yeah, thanks for that awesome request. And then so the Empress Alexis Hope, Your Majesty, you wanted to look at Libra, but unfortunately, Your Majesty, we can't, because Libra is an entire constellation, and we can only see small, tiny parts of constellations. And we could actually point at a specific object in Libra, although I don't have any that come to mind at the moment, that is located in the constellation, if that will satisfy you. And then also, because you've also requested Venus, Venus is actually up in the very early evening right now. So you can pretty much only see Venus on the western horizon just after the sun sets. But since we're talking about it, Next week, I don't remember the exact date now that I'm thinking about it, but next week there will be a conjunction between Venus and Mercury. And so if you go out really early after sunset, and you want the sun to be completely set because you might accidentally look at the sun when you're trying to look at Mercury. You can actually catch Venus and Mercury very close together in the sky, and you can point some binoculars at it and get a pretty good view of both of them at the same time. So that's an early sunset, but of course, over the course of the next 6 months or so, we're going to see Venus getting higher and higher in the sky in the evening time. All right, so Astrochironiae, I'm so sorry if I pronounced that wrong, has requested Messier 3, which is a globular cluster over in Canis Venatici. So let's go ahead and get an M3. This one is a fan favorite with us educators here over at Lowell Observatory. M3 is one of the first globular clusters that you can get in the year. We tend to not be able to see very many globular clusters during the winter time because most of them are very near Sagittarius in the center of our galaxy, which is up in the summer. So in the springtime, Messier 3 is usually the first one that you can see for the start of our globular cluster season. Okay, so we do have some, so we do have some clouds in the way. I think what we'll do is we'll try and circle back to this one in case, so if that cloud ever moves out of the way, we can look at it because I do want to see it. So why don't we go ahead and let's look at some binary stars here. Because Grant Owens has requested a non-binary star, and that's actually really funny. I'm gonna just laugh at that forever. So let's look at a binary star. Let's get up Algoba. That's a really nice one. That one's located in Leo, and we can. These two stars are very close to each other in the sky, and they are circling each other. They're orbiting a common center of mass, and they're so close to each other that with the naked eye they look like one singular star. But if you get a telescope that is big enough or magnification that's small enough, you can actually resolve the two stars from each other, and you can tell that this one is a little bit lopsided looking. It's not a circle, and if we get the exposure just where it's supposed to be, you can actually tell that there's two stars there. And for the person who requested the non-binary star, we could also look at singular stars, because that's not part of a binary system, and I guess any star clusters that are more than two as well. So yeah, well, it looks like we do have some clouds that are kind of around, and we're going to just try and dodge those a little bit as we can. Oh yeah, this one's Algoba, and these ones often look really like kind of gold in color. They're located in the constellation Leo. I think they're a really pretty star binary star to look at. Book Davies has requested NGC 4753, and yeah, we haven't actually looked at this one with the Melon Cam either, and so we're not too sure how good it's going to look, but we might as well give it a try. It's located over in, it's one of those galaxies that's located in Virgo, and this is about 60 million light years away. So that's basically right at the heart of the Virgo cluster. The center of the Virgo cluster is probably about 60 to 100 million light years from us. So we are probably getting some clouds here as well. So an unlucky night for stargazing for sure. But I saw a blob right before they zoomed out, and then the blob went away when they zoomed out. So I was able to like sort of pick out where the galaxy should be on here. As you can see, there's a star that isn't as crisp and clear at the very center, and it's kind of got a cloud around it that's not an Earth cloud. That's our galaxy right there. NGC 4753, which is what I think I said it was. but yeah, so yeah, this galaxy, I haven't looked at it before. I'm pretty excited about it. But yeah, thanks for that recommendation book. And then Curtis Horn has recommended Caldwell 35. And so this one is another one that we can try and get, but we're not too sure how well it's going to look or how good it's going to look. And then Curtis has also suggested a longer exposure on this one. So that's probably a pretty good hint that we should do that. So what they're doing right here is they're trying to find it. So usually we have the local catalog, which contains pretty much all the Messier objects and the NGC objects. And then we can do quick searches online using this. And it looks like they're trying to find it, and they might be, we're gonna have to probably use a different catalog number for it to get this. So this one is NGC 4889. So we're gonna move the telescope quickly over to there and take a quick look at this, which is another galaxy. So Caldwell 35, or NGC 4889, is a giant elliptical galaxy. So as I mentioned, elliptical galaxies are the combination of a whole bunch of galaxies that just got together, right? And this one is about 330 million light years away. So this one is one of the farther ones that we'll be looking at. This is actually probably one of the farthest galaxies that I've looked at all. There's a fuzzy blob there. There's a cloud in the way, but there's definitely a little blob right there in the center. And that we'll let the operator see if they can find it, because I'm looking right at it's very faint, very faint. But it's kind of like right in the center, but towards the top a little bit. So yeah, they have it right. They've moved that to the center. It kind of looks like, and again, a little fuzzy star. It's like a star that has kind of been scribbled out a little bit or erased a little bit. It's not super bright, but that's it. So this is a very, very distant galaxy. This one I would not say is in the Virgo cluster at all. It's much too far. Yeah, another giant elliptical. I do love these galaxies. They're some of my favorites because just the process that goes into making them is pretty intense. How about we move to Messier 94? So Astro Chiranae has requested that one in lieu of Messier 3, since we couldn't get M3. This is a spiral galaxy, so we're waiting on that exposure to come in a little bit. Yeah, the clouds apparently have built and are just sitting right over us. So here on Flagstaff, we're on a mountaintop pretty much. We're on a mountaintop. And what happens here pretty frequently is clouds, they don't just move in. They're not moving from sometimes they're moving from California over to us, but most of the times these clouds, they start building here. We're the source of the clouds. So we tend to just have them, even though you don't expect it to be a cloudy night, they kind of just appear. Flagstaff does have a little bit of an unpredictable weather. So at this moment, we're gonna go ahead and try and just do some of the brightest things that we can get. We have part of the sky. Since I'm inside, Yeah, since I'm inside, I don't have a very good view of what the clouds look like, but my colleagues do. And one of them has actually suggested another binary star. So we're going to move over to, I just found out about this binary star. It's called Iota Cancri. You can see it's spelled right there. I just found out about this star this year. One of my other colleagues is like, yeah, this star is great. It's like the Albireo of the winter. Albireo is a star in the summertime that's really bright, wonderful to see. And it's a bicolored star, meaning each star are two different colors. And so you can actually tell, excuse me, you can tell if we get the exposure and all the video settings set up properly, that they are two different colored stars. We'll have a red star, or it'll be kind of like an orangey gold, and then we'll have a blue star as well. And that one is pretty obviously blue as well. There it is. You can see both of them, and you can tell the color. You can tell which one's red and which one's blue right there. Now, the differences in colors of stars can tell us about the temperature. And so believe it or not, the red star is the cooler temperature star. So all of our faucet companies, they've been lying to us our whole lives. Blue means hot and red means cold. So that blue star, even though you can tell it's not as bright, so it's not as bright as the red one, but it is burning a lot hotter. And that red one there is a lot cooler in temperature. And these stars, again, they are orbiting a common center of mass. They're orbiting around each other. So there could be a planet around there that's just like Tatooine. You never know. But yeah, Iota Cancri. So when we when we name our stars, typically all of the stars that have names, those were named thousands of years ago by stargazers, and those have just stuck over the generations. But astronomers like things to be like orderly and cataloged, and so all the brightest stars will be named with they'll be named with Greek letters, and the brightest star will be Alpha, and then it'll go down the list of the Greek alphabet. So Iota is basically the Greek letter I. It's somewhere in the middle. So this star is certainly not the brightest star in the constellation Cancer at all. We can also, since we're kind of cloud dodging at this point, why don't we go ahead and we look at the Leo triplet, or 2/3 of the Leo triplet, because we can't get all three of them with our Melancam because the field of view is just a little bit too small. But I can certainly get you the better two of the three. We have Messier 66 and Messier 65. And then there's the third lesser known one that I always forget because it's not a Messier number. And so those should pop up. We can get those if the clouds are staying out of Leo's sight, then we should be able to see those pretty easily. And so now we're just waiting with bated breath for the two pictures. And we're gonna have one right in the center, and then there's one off to the far left over there as well. So that one, I already missed it. I didn't see which one they typed in. I think the far right one, the right one there, I think that's Messier 65, and then 66 is going to be the left one, and I could have those backwards. So Messier 66 is the one in the middle, and then the one on the far left is 65. And so again, we have a pair of spiral galaxies. You can actually see the spiral structure pretty well with both of these here. These are galaxies that are physically near each other, not just from our perspective as well. And then that third galaxy, that's also near them. And these are kind of like they're a little bit farther, but they're getting pretty close to where the Virgo cluster is. They're part of our Leo Virgo galaxy sky here. The Leo triplet is always a fan favorite, something to look at, because you can see two galaxies at the same time. And I always just think that's the bee's knees. That's what. Anytime that I can see two galaxies at once, I just get really excited about it. We can also try M101 again, because I guess the clouds moved. Oh no, just kidding. The clouds moved again. And so Messier 101 is out of the question. Can we get Messier 3 yet? Is Canis Venatici cleared off? Can we fulfill that request? They're gonna try. They're moving to it right now. I'd be pretty sad if I didn't get to see a globular cluster tonight. Globular cluster season is basically coming just around the corner. Oh, no. You can't really see it. It's all yellow there. There's like a bright white spot in the center, and that's our globular cluster. But yeah, there is still a cloud over there. But yeah, the spring sky and the spring sky and the summer sky are great for globs. We have the Hercules cluster that's also in the sky right now, which is Messier 13. We have M96 also in Hercules, and then pretty soon we're going to have a few more coming up with Sagittarius. This cloud seems to be moving pretty quickly, so we're going to just do it a couple more exposures and see if it goes away. But I've recently been informed that Mars is still in the sky, and there are no clouds in front of Mars. And we might as well get a few last looks at Mars. Mars is starting to sink below the horizon. It's getting closer and closer to the horizon every single day. It's in the constellation Gemini, and Gemini is starting to go away for the year as well until it comes back in the winter time. And pretty soon, Mars will be on the other side of the sun. It's starting to make a loop right around to the backside of the sun there. And Mars is about as far away from us as it can get at this point. So we have periods when planets are the best to be seen, and that's when they're at opposition. And that means that the Earth is going to be between the sun and that planet. And Mars had opposition for about 6 months ago now, back in October. I have no concept of time. And that was when it was the biggest and brightest. And so now it's kind of going back to the far, far, far side of the sun. And soon it's going to be gone. And we're not going to see it for quite a while until it comes back for its next opposition, probably a year from now or so. All right. But yeah, you can see Mars is this little red circle right at the center. Mars is really special here for us at Lowell Observatory because it's the whole reason that the observatory is even here. Our founder, Percival Lowell, he wanted to study Mars. He had heard about some of these canali from a Italian astronomer, Giovanni Schiaparelli. And canali in Italian is channels, like river channels. Percival Lowell, he was a very creative and an imaginative fellow, and he was thinking, oh, canals, like what people like dig, like what a boat got stuck in a couple weeks ago, or like what you dig to, go from one side of the Atlantic to the other side of the Pacific, and that sort of stuff. So he was thinking that there might be these people on Mars building these big canals. So I was thinking, well, the only source of water is the polar ice caps. By the way, there are polar ice caps, but they're not made of water on Mars. And he was thinking that maybe they were moving the water to the equator by digging these big canals. So he founded this observatory. He had our famous Clark telescope built specifically so he could study and watch Mars. And so he spent his whole life trying to study these canals. And of course, we know that like Mars, it does have water underneath its surface, and most of it's frozen. So it's going away. Bye, Mars. There is water on Mars, but it's not on the surface that we can see at all whatsoever. Mars is pretty much a dried up planet. And those polar ice caps are actually made of frozen CO2. All right, so let's go ahead, and we do have a request for Messier 104, which is the Sombrero Galaxy, since we're talking about things that are important with Percival Lowell and all of our history here. So we're gonna go right over to Messier 104, the Sombrero Galaxy. And this is another one of those lenticular galaxies, and it's located over in the southern sky right now. And it's in Virgo, it's kind of near Corvus. Now, back in the early 20th century, one of our astronomers, Vestos Lifer, look, it looks really good tonight. We got some star trails in there. We're going to take another picture, get rid of those. But Vestos Lifer was observing several spiral galaxies, or at the time, he called them spiral nebulae. And he was using spectroscopy to observe these. And he detected with all but one of them that there was a redshift in their spectra, which meant that they were all moving away from the Earth or away from our solar system. And this one was the first one that he detected the redshift with. Now, this redshift implies that the universe is expanding, and he took all of the data, and Edwin Hubble was the one who used that data to come up with this theory that the universe is expanding. And so all of that, the theory of the expanding universe, that kind of started here at Lowell with us. And so the sombrero is pretty important when it comes to that. So yeah, this one is always another fan favorite here at Lowell. It's bright enough that we can see it in some of our smaller telescopes. We're going to go ahead and we're going to go back to the moon. This will be the last object. Since we're getting kind of clouded out here, we're going to go back to the moon, and we're going to kind of end here with that. And so since we're looking at the moon, I'm going to have to mention to you guys that on May 26th, on the morning of May 26th, if you go to bed really, really late, or if you wake up really early, there is a total lunar eclipse that's happening. And here in Flagstaff, we're going to see this lunar eclipse is going to be happening. It's going to start at about 1:45 in the morning or so, and it's going to go on for a couple hours. But we're going to, at Lowell Observatory, we're going to stream the lunar eclipse onto our YouTube page. So if you like to get up early in the morning, and you can definitely watch, you can go outside and you can watch it, and it's going to, in the northern hemisphere, it kind of looks like it's in the southern sky because it's starting to set. But if you live farther south, I believe that if you're in South America and in parts of Asia, it's going to be much better for you to go out and see. You're going to have it much higher in the sky for you. But yeah, we're going to be doing that live stream on May 26th. And I'm sure that some of my colleagues can post a link to that when the time comes as well. And yeah, so a total lunar eclipse happens when the moon passes directly in the Earth's shadow. The link is already posted, right? So we already have it on our YouTube page. You can go sit there and wait for it for the next 6 days if you'd like. But yeah, lunar eclipse happens when the moon passes directly in the Earth's shadow cast from the sunlight, and then it turns like this dark red color because the sunlight that passes through the Earth's atmosphere gets refracted and it starts to shine on the moon. So all of those bluer colors, they kind of scatter away, but the red light still makes it through. And so the moon tends to turn a dark red. And so this is where it gets the nickname of the blood moon, which sounds really scary, but it's not that scary. Lunar eclipses happen pretty frequently. You will probably get one about twice a year or so. And you generally have a total or annular solar eclipse accompanying a lunar eclipse, either 2 weeks before or 2 weeks after. And it's always good to know that this one's also a supermoon, and a supermoon happens when the full moon, right, is also at perigee. So the moon isn't orbiting the Earth on a perfectly circular orbit. It's on an elliptical orbit, which means that sometimes the moon is closer to the Earth and sometimes it's farther away. And perigee is the word that we use when the moon is at its closest distance, which means that it's actually going to look a little bit bigger and a little bit brighter in the sky than you would see when it's farther away. And it generally, compared to the average full moon, it generally tends to look about 14% bigger or so. This is not something that I really am able to notice with my naked eye, but it does tend to be noticeable by other people as well. So with that, I want to thank everyone who came to watch our interactive stargazing. Even though we kind of had some rotten luck with the clouds, we still got to see some really neat galaxies and some stars in the moon as well. The moon's always spectacular. So I want to thank everybody for joining us today. And also we have to thank our telescope operator, Nina, for doing such a wonderful job. And I can't wait to see you guys for our great big lunar eclipse that happens next week. And thank you all very much. Have a good day. Night. Or if it's day where you are, have a good day.